Hello students, and welcome back to another algebra video. Same as usual, pause the video and try these problems in your notes, then unpause them to do them with me. Okay, we are solving literal equations. The first one tells me to solve for y. That means I want y equals something. So, I'm going to look over here at my equation. I want the y by itself. That means that I need to get rid of this x. The opposite of negative x is positive x. That'll get rid of this on this side. I'm left with 3y equals 9 plus x. Remember, I cannot put those together. This is an orange, this is an apple. Cannot put apples and oranges together. Now, I am left with 3 times y. The opposite of times is, you got it, division. So I'm going to divide by 3 on both sides. And now I am left with y equals 9 divided by 3 plus x divided by 3. Now remember, in front of every x is an invisible 1. So you can actually write this as 1/3 times x. Okay, and we can write this, we can simplify even further. 9 divided by 3 is 3. And then a 1/3 x can't simplify anymore. So there you have it. Y equals 3 plus 1/3 x. All right, new color, new problem. Now we want to solve for x. That means I'm getting x equals something. So first thing I notice is that, I have an x here and an x here. That means that I can pull an x out. So we have 3 plus. I want to pull that x out. I wrote the 3 plus because the 3 doesn't have an x. 3 doesn't have an x, so there's no x we can pull out. You just leave the 3 over there. But now we're pulling an x out, and if I get rid of an x here, I'm left with 5. And if I get rid of an x here, I'm left with minus k. Equals y. Don't lose your equal sign. Okay, now remember I'm getting x by itself, so I'm still looking at this side. Before I divide, remember you want to do what's furthest away from the x first. So before I divide, I need to deal with this 3. And I will do that by doing the opposite of positive 3, which is negative 3. So let's subtract 3 from both sides. We are left with x times 5 minus k equals y minus 3. Remember, apple, orange. And in fact, you could say this is something different because the x is an apple, but the y is like a tangerine or something. So you can even call it something different. All right, now x times 5 minus k. We want to get the x by itself. We are running out of space. We are going to divide by 5 minus k on both sides. Oof! That'll get rid of this. Let's rewrite this over here so it's easier to see. We have x equals y minus 3 divided by 5 minus k. Woo! That's not simplifying. We have a y and we have a k. No. This is as simple as it gets. You could rewrite this in some other form, but let's not. Let's not make things more complicated than we need to. We have x by itself. We did the x equals something. We got it in that form, so that is our final answer. Woohoo! How did that feel? If you got them, awesome. If you didn't, maybe brush up on the last video that we watched. At the end of the video, there's always a link to the playlist of all the algebra videos, so you can look through and find the video before this one. Okay, let's move on to what we have for today. We are finishing up Chapter 1 today, actually. This is the last video in Chapter 1. And it is on the second half of 1.5, section 1.5. So now we're going to talk about formulas today. What is a formula? You might already know what a formula is. Maybe you remember it from a previous class. If not, that's okay. We're going to talk about what it is. So the success criteria is that you can rewrite and use common formulas. So maybe formulas that you've seen before, but you've never written. Like maybe you know the area of a rectangle is length times width, or base times height, however you learned it. So maybe you know this formula, but if you have this, what is the height equal to? Ooh, we're going to learn how to solve for, how to rewrite, common formulas. That you've probably seen the formulas before, but you've never rewritten them before. So that is our success criteria for today. Rewrite and use common formulas. So, vocab, just in case you've forgotten, what is a formula? I would recommend pausing the video and writing this down. A formula is a literal equation, so that means that it has more than one variable. It has at least two variables in it. A literal equation that shows how one variable is related to other variables. So, one variable is related to other variables. So the area is related to the length and the width because it is the product of the length and the width. Same thing with interest and distance. We are going to learn about interest in particular today. We're going to talk about temperatures and interest. And of course, here's the Spanish, should you need it. So, important information. We are going to look at temperature and simple interest today. So, Fahrenheit. All of our temperatures are in Fahrenheit. You hear people say that it's going to be 93 degrees Fahrenheit tomorrow, or it'll be 30 degrees Fahrenheit, or something like that. Basically, the rest of the world uses Celsius. We're like one of 2 or 3 countries that still uses the imperial system. Celsius is what is used more commonly in other countries and the world. Kelvin is another one that maybe you'll hear about in one of your science. I don't know. But so we're going to talk about how to get from Fahrenheit to Celsius, how to get from Celsius to Fahrenheit. So we want to be able to change between the two so that we know what the other what the rest of the world is talking about. Simple interest. How many of you like money? Yeah. A lot of us do. So interest, if you put your money in a bank, you get interest. If you buy something with a credit card, you have to pay interest. So we're going to learn about simple interest today, the most simple kind of interest, so that you know a little bit more about how money works. Okay, and then this is another very important formula, especially if you do anything related to physics. Distance traveled is equal to the rate times the time. And we're not going to look at this one explicitly, but I wanted to put it here so that you've seen it before. Okay, let's jump right into it and talk about temperature. To do that, I am going to write the formula for Celsius right here on the next slide down. So Celsius equals 5/9 times Fahrenheit minus 32. Now we could talk about where this formula comes from and how 32 is the freezing point. We could talk about all that, but let's not for now. Let's just trust the formula. Okay, so we are told that Mercury is 427 degrees Celsius and that Venus is 864 degrees Fahrenheit. We want to know which has the greater surface temperature, Mercury or Mars. Which one is hotter? Now you might be thinking, oh, duh, Venus 864 is bigger than 427, but we don't know what this is. This is Celsius, this is Fahrenheit. We can't compare Celsius and Fahrenheit. That's like comparing apples and oranges. We can't do that. So we need to make sure, we need to put them both in terms of Celsius or both in terms of Fahrenheit so that we know we can compare them. Because which planet is closer to the sun? Maybe that's the hotter one. I don't know. That's just what I would think. If you're closer to the sun, you got more sun, more heat flowing on you. Okay, so let's see. We want to convert these. We want to convert one from Fahrenheit to Celsius or from Celsius to Fahrenheit. It doesn't matter which you choose. You could turn Mercury into Fahrenheit, or you could turn Venus into Celsius. If you're doing this on some sort of SAT test and this is the formula they give you, they tell you how to find Celsius right there. Because we're in a chapter about literal equations, I want to show you how to turn Celsius into Fahrenheit. So, there are many different ways we can do this, and if you want to pause the video and try it yourself and see if you do it a different way than me, go for it. Go for it. But here is one of the ways that we can do this. If I solve this equation for Fahrenheit, I can plug in the degrees Celsius and figure out what the Fahrenheit is. So, let me solve this equation for F. Let's solve for Fahrenheit. And again, there are many different ways you can do this problem. I just want to show you how to rewrite literal equations like we did in the last video. So, in order to solve for F, first, I need to do what's furthest away from the F. So this 32 is right in there with the F, so we're going to leave that for later. Right now, we're going to get rid of this 5/9. Now, the way we get rid of a fraction like this is I am going to multiply. I'm going to put a 9 on the top and a 5 on the bottom. Because remember, 9 over 9, that just goes away. That's equal to 1. And 5 over 5, those go away, and that's equal to 1. So, if I multiply by 9/5 on both sides, remember, can't do it on just one or our teeter-totter is unbalanced, these will go away, and I get 9/5 Celsius equals Fahrenheit minus 32. Or F minus 32. Okay, now remember I want to solve for F. That means I'm getting F equals whatever. F needs to be by itself. So, let's add 32 to both sides of the equation. And now I have, these have gone away, and I get 9/5 Celsius plus 32 is equal to Fahrenheit. Cool. So now, if I take, do different color, if I take this right here, Mercury is 427 degrees Celsius. If I plug this in for C, so we'll do 9/5 times this Celsius temperature right here, plus 32. That's going to tell us what the temperature is in Fahrenheit. And that way I can see this Fahrenheit and this Fahrenheit. I can see which one is bigger. Then I'll know which one has the greater surface temperature. So let's do that, and let's do it over here so that we can see a little bit better. 9/5 times 427 plus 32 equals Fahrenheit. Okay, so 9/5 times 427, so I'm going to do 9 times 427 divided by 5 is 768.6 plus 32 equals F. So 768.6 plus 32 is 800.6 equals Fahrenheit. So Mercury Mercury is 800.6 degrees. So which is hotter? We have Venus. Venus is 864 degrees Fahrenheit, or Mercury is 800.6 degrees Fahrenheit. This one's hotter. This number is bigger. So Venus is actually hotter. Interesting. It's a good thing. It's a very good thing that we converted, because I totally thought that the planet closer to the sun was going to be hotter. Now, we can make sure that we did this right. Maybe I made a mistake. Everybody makes mistakes. So let's see. Oh no, look at that. Convert the Celsius temperature of Mercury to degrees Fahrenheit. So we had, yep, this is what we had. Plugged in 427, we got 800.6. So Venus has the greatest surface temperature. We were right. Isn't that weird? Totally thought Mercury would be hotter. You learn something new every day. Okay, so that was our example about temperature. Now, let's talk about money. So, simple interest. Again, let's go back and write down what the formula was for simple interest. So simple interest was right here. And this is actually very important. We have that I is equal to interest. That's how much interest you'll have at the end, how much you'll earn in interest. P is the principal. This is your starting money. Starting money. This is how much money you have at the beginning. R is the annual interest rate. So R for rate, interest rate. You always want to have that in a decimal form. And T is time. That is typical. T will usually be time. Okay, so let's take this. I equals PRT. I equals PRT. Equals PRT. Okay, so you deposit $5,000 in an account. So we are starting with $5,000. We're depositing that. So that's what we have in the beginning. So this, our starting money, is our principal, which is what P stands for. So we already know that P is 5,000. In an account that earns simple interest, this tells us that we're allowed to use this formula. So that's good. After 6 months, so this is T, and let's see, was T time in years? This is important. 6 months is not the same as years. In fact, 6 months is half of a year. So it's very important to pay attention. Is T in years or in months? Because this formula won't work if you put in months instead of years. Okay, so after 6 months, that gives us T. The account earns $162 in interest. So this is our I. I is the interest that we earn. Whoops. And we earn $162.50 in interest. So we're going to rewrite this equation. We're going to rewrite this equation given what we know now. So I, we just learned, is $162.50. So instead of I'm going to write 162.50 equals P. We learned P is the principal, and that was $5,000. So instead of P, I'm going to write 5,000. R. They didn't tell us anything about R. But we didn't read the last part. It said, what is the annual interest rate? The interest rate is R, and it's saying, what is R? We don't know. So we don't know what R is, but that's what it wants us to find out. What is R? So that's what we're trying to find out. So we're just going to leave the R there because we don't know what R is. So we'll just leave it there. And now, t. We learned earlier that t is half a year. So we can write this as times 1/2, or if you like decimals better, you can do times 0.5, whichever you like better. It does not matter. 0.5 and 1/2 are the same thing. Okay, but now we want to know what the interest rate is. So we need to solve for r. We need to figure out what r is. So remember that we can rewrite this. 3 times 4 is the same thing as 4 times 3. Doesn't matter how you write it. So I'm going to rewrite this. And remember that you don't need the 0 on the end of that either. We can just leave it as 0.5. It's the same thing as 0.50. Okay. Equals 0.5 times 5,000 times r. So now I can do this. I don't know what half of r is, but I do know what half of 5,000 is. 1/2 of 5,000 is 2,500 times r. And hey, we know how to solve this equation. We have 2,500 times r, so let's divide by 2,500 on both sides of our equation. And we get, let's see, 162.5 divided by 2,500. That is, I'll write it over here, 0.065 equals r. Great. Does that mean the interest rate is 0.065? No, remember, this is in decimal form. Interest rates, they give it to you in a percentage. So we need to turn this into a percentage. Do you remember how to turn a decimal into a percent? If you don't, that's okay. What you do is you take the decimal right here and you you move it over twice. You multiply by 100. Moving the decimal twice and multiplying by 100 is the same thing. But if I move that decimal place over twice, now I have 6.5. And remember, I don't need that 0 in front of it. 0.6. Same thing as 6. It's just redundant to write the 0. So this decimal, 0.065, as a percent is 6.5%. So the annual interest rate is 6.5%. That is not a bad interest rate. That is a good interest rate. If you find that interest rate, you snatch it up, okay? All right. So there we go. It asked us what the annual interest rate was, and we found 6.5%. Beautiful. Were we right? 0.065 or 6.5%? We were correct. Woohoo! They solved it a little bit differently than us. That's okay. This works in exactly the same way, and unless your teacher tells you to solve it a certain way because they want you to practice thinking about it a certain way, on the SAT, on the SBA, they don't care how you solve it. They care that you thought through it logically and that you found the correct answer. But the logical thinking is the most important thing that matters, not the correct answer. Alrighty. So, today we talked about interest, simple interest, and temperature. How did it feel? Feel good? Feel bad? Are you a thumbs up? Are you a thumbs down? Are you a thumbs sideways? What are you? If you are a thumbs sideways, I would recommend rewatching this video and maybe trying some of the practice problems that we have for you. They are straight from the textbook. And if you're a thumbs down, or a thumbs down, I would recommend calling a friend, texting a friend, asking your teacher, comment on this YouTube video. Make sure that you get the help that you need. And like I said earlier, here are the practice problems. If you are a thumbs up, I would still recommend trying these practice problems because word problems, I think they stretch your brain a little bit more than just solve for x. Like, okay, I guess I can just do the procedure and solve for x. But these help you actually like use, okay, I'm solving for an interest rate now. What is the interest rate? You know, there's more pieces to the puzzle, and the more pieces that are in a puzzle, the more you have to work at it. The more you work at it, the more your brain grows, and that's what we're trying to do here, is grow our brains. So, try those practice problems if you'd like, and as usual, I'm going to send you off with a launch. Today's launch comes from Maya Angelou, and she says, try to be a rainbow in someone else's cloud. So right, when we think of clouds, we think of if we're having a cloudy day, we're kind of bummed out, we're maybe not feeling so great. But rainbows, when we think of rainbows, they're bright, they're colorful, they bring a smile to your face. So if you see somebody else having a cloud, or maybe you don't even know that Jared's got a cloud hanging over him, but if you can just try to be a rainbow for someone else, smile at them, give them a random compliment. Hey, your hair looks really great today. Oh my gosh, I love those shoes. Or even if it's somebody that you know, hey, I really appreciate your friendship. You are always there for me and I love that. Or, hey, you said hi to me in class the other day. Nobody ever talks to me and I really appreciate that. Be a rainbow in somebody else's cloud. Compliment people randomly. Make them smile when you can. Work to help other people have a better day. Try to be a rainbow in somebody else's cloud. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.